Hey, what's up, guys? This is Sheng here. So this time, LeetCode number 978, longest turbulent subarray, right? So this time you're given like array, uh, and then we need to find the turbulent. So what is the turbulent? Turbulent is arrays that every adjacent pair of elements, the comparison sign will be flipped, right? So which means that if the first one, right? So basically, if the first one is greater than the second one, right? And then the second one has to be smaller than the third one. And then the third one has to be greater than the fourth one, so on and so forth, right? And it asks us to find the longest one, right? And so it has to be strictly greater or smaller, right? So equal doesn't count. That's why, for example, this one, the answer is 5 because we have 4, 4 is greater than 2, 2 is smaller than 10, 10 is greater than 7, 7 is smaller than 8, but 8 is equal to 8. That's why we stop at here. That's why the answer is 5, right? 4 comparisons, and then we do a plus 1 in the end. Okay, and so that's a constraint, right? I mean, this one apparently the brutal force is that at each of the location, right? At each of the location I here, we can just either go left or go right, trying to find uh, we should find out the longest one, right? Starting from I here, we go to left all the way until we couldn't find it, until we couldn't find like uh, a reverse sign here, right? So we're assuming this current one ending at I, right? That's how we check that. But but this one is a in square time complexity, right? That's why I do a TLE. So this one we can use DP, right? The dynamic programming concept, because let's say we're at I here, right? We're at I. So basically this DPI means that we're assuming the current I this turbulent array ending with I, right? So basically, if we know, then we can compare the numbers I and I minus one, right? And I minus one, if the I is greater than I minus one, right? So if I is greater, if this one is greater than I minus one, then what does it mean? Then if we know ending with I minus one, if it's if it's smaller for this one, right? If it's like, yeah, if I minus one is smaller than the previous one, then we don't have to go all the way back, right? That's why for this DP we need two values, right? So basically we need to have greater I, and then we have a smaller I. I'm not sure if this name is proper enough. Smaller I. So this one means that ending with I, right? Ending with I, and then the last, and I is greater than I minus one, right? So this one is similar. This one is the I is smaller. I is smaller than I minus one, right? So if we can define this two DP array here, then at each I here, right, depending on the comparison result for this I and I minus one, we can choose to use the either smaller one or the greater one, right? Because if I is greater than I minus one, right, then we know, okay, we can use the smaller one because we want to know ending with when ending with I minus one, and the last one the last sign is small, right? Because the current one is greater. So same thing, if the current one is smaller than I minus one, then we know, okay, we need to use the greater one array here, just so that we can make sure the array it can be guaranteed as a turbulent array, right? And apparently, when these two are the same, we can just skip that because we know if it's the same, we don't need to go basically the answer for this I will be 1, right? Just the number itself. And yeah, so as you guys can see, so in this way, right, we just need to go through one for loop, because at each of the index here, we can just use the previously calculated result, either smaller one or greater one, instead of going all the way back, right? Yeah, so let's start coding. And so we have n equals this r, and then we have a greater, right? So I initiate everything into 1 because the minimum answer for this problem is always 1, because the number itself can construct a length 1 turbulent array, right? That's why at each of the location, the default value is always 1. And for I in range of 1 to n, right? So if array, so we start from the second one, okay? If the current one is greater than array of I minus 1, right? And then okay, so if that's the case, right, then the greater I, right, going to be equal to the smaller of I minus 1 plus 1, right? So this means that, since the current one is greater than since the I is greater than I minus 1, then we know, okay, the greater I means that, ending with ending with I, and the last sign is greater, we can just use that. We can just we will need to update that one with a smaller I minus 1, right? Similarly, right, if the I is smaller than array dot I minus 1, if that's the case, then we know, okay, so this one, the current value is smaller. That's why we will update the smaller one, right, with a greater I minus 1 plus 1, right? So in the end, we just do this, right? Because the turbulent array can end at any position. That's why we just need to do another max here. Or we can do this. Actually, we can do this. Let's do this. Let's do answer is equal to 0. Equals to 1, actually. You can do this. So answer is going to be the max of answer dot greater I or the smaller I, right? Okay. Yeah, we just update the answer along the way, right? And yeah, I think that's it. So, right, see? So it works, right? Yeah, as you guys can see, the time complexity is O of n, right? We only have this for loop here. And the space complexity is also O of n, right? But if you guys take a look, so either the greater I or smaller I, always depending on the I minus 1, right? So that's why we can just improve this space complexity from O of n to O of 1, right? How should we do it? Easy. We just first we instead of array, we simply use like a variable, right? And here, since we're going to update that, that's why we're gonna create like a two temp variables, right? So it's gonna be smaller 1, right, equals to greater 1 equals to 1, right? So because that's how we start those things, right? And then we do a greater 1, right, equals to smaller. Basically, the greater one and the smaller one will be the new greater and smaller, and this smaller greater will be the old one, right? So, and we simply just replace them respectively, right? This one is going to be a smaller one, and this is going to be a greater, right? Okay, and then in the end, don't forget, okay, yeah, we can keep this one here. So it's going to be a greater 1, smaller 1, right? And then in the end, don't forget to assign them back, right? So basically the greater is going to be the greater one, right? And smaller, it will be the smaller one, right? So this should just work, right? So now we only have a constant space complexity now, right? Yeah, I think that's it, right? I mean, it's a pretty basic DP problem, right? Based on the comparison result, right, of the current one, the previous one, we choose to use either the smaller one or the greater one, right? And then in the end, we just combine both of them to get the max number, max max length of the turbulent array. Um, cool. I think that's it for this one, and thank you for watching this video, guys. Stay tuned. See you guys soon. Bye bye.